how about we take a rest from the practical sides, take a rest from papers, etc. And let's talk theory a little bit more. Let's resume back to theory. And then again, we will go back to practice in the upcoming video. Now, what we need to understand is that IPv4, when it was released, 70s, it has been like 50 years or 45 years, something like that. Regardless, when it was released, it was classified. Upon releasing, it was classified. And you will use based on the class, based on your needs. That was the rule, was. We are about to break the rule in the next video. The rule said is that IPv4 started from class A, which is the very first IP 1 dot whatever, because it was a /8, meaning that all these 3 octets were a host portion, accepting over 16 million possibility up until the end of 126, meaning that 1 dot whatever, 2 dot whatever, 5 dot whatever, 100 dot whatever, until we reach 126 dot whatever, the end of class A. All of them were /8. Class B starts right after that, 128, but this time it was 16, meaning that these 2 octets were the host portion. So 128.0 dot something is a network, but 128.1 dot something is another network, up until the end of 191.255 dot some host portions. And then comes class C, also right after that, after 21, 22, from the very beginning. Everything here was a /24. So 192.0.0 is a network portion. This is a host portion. 192.0.1 is a network portion for a new network, and then a host portion. And keep incrementing based on what we have studied in the past 4 videos until we reach the end of 223. 223. Now, the truth is that these were your edge or the borders of what you use oftenly and what you don't use oftenly and you might never use at all. The first 3 classes were the day-by-day usage of IPv4 worldwide ever since IPv4 until today. Class D is a /8 starting from 224 until the end of 39. It was reserved for the domain of multicast. Now, this is out of the scope of this course completely, but whenever you are studying a CCNA Chapter 1, a CCNP Core Network Insurance or IP Services chapter, any other Huawei, Juniper, Nokia, let's say, courses, you will study multicast and you will understand that worldwide, between 224 till the end of 239 is an IPv4 addresses that are used for the technology of multicast and multicast only. We will not be using it for the gradual normal usage of IPv4, just like the first 3 classes. And the 5th and final class is reserved for study purposes. Have I read that well? Reserved. I believe it's correct, spelled correctly. Meaning you will never see it. You will never see IP addresses of this range, except sometimes for this broadcast of the broadcasts, but you will never see it as a normal IP address to be used. Now, this is a general explanation of the classes that you need to memorize for a job interview, an exam, regardless of the vendor, because everything in this course is general. Nothing is vendor specific. Everything in this course is 100% general, open standard. So this is the general view. First 3 to be used. 4th and 5th is to be, let's say, reserved for some special uses, for some uses that I might never see in my life. All right. It means that you have started from the very first IP address up until the last IP address, but they were classified correct. No, you're lying. Why? Because this is not the very first IP address. We agreed on an octet can start from 0. So where is this? Where is this? Where is this? Where are they? The 0/8 was also reserved. Yes, you will see in routing 0, 0, 0, 0. That is correct. It has a specific usage. When you study the routing fundamentals, you will understand what I am saying. But an IP address for a computer, for a router, for a user, just like we did in the previous 5 examples, a valid range of 0, no, reserved. Exception number 1, the zeros. Exception number 2 is in front of your eyes. You ended with 26, you started with 28. Where is 127? What is that? .000/8. This was taken and named as the loopback addressing to be used inside network devices between the components, the internal component of the device, within the operating system, within a router, within whatever. So this has special uses that you will not be using for normal devices. Also reserved and deducted. The third and the last exception, based on what you are seeing in front of your eyes right now, is 169.254/16, which lies between these two numbers and has a /16, so it's a Class B subnet that was also deducted or reserved. This was taken by, or let's say it was reserved for a technique called automatic private internet protocol addressing, a PIPA. Whenever a computer operates, it cannot operate without an IP. If you haven't yet designed and implemented the IP for the computer, it will take a random number for itself from this range and operate, just to operate. These are the 3 exceptions that you need to understand. Now, what does classful mean? It means that if you have a computer, a network computer of a switch with 3 devices, and you wanted to use or design IP addresses for them starting with 10 dot something, then you are forced, unfortunately, based until the mid-90s, I believe, of the previous century, to have it as a /8. Are you referring to that I am about to waste over 16 million IP address that they belong to a /8 network of 10 dot something for a real network of only 3 computers? Yes. That was the catastrophe of the classful IPv4 addressing. You use an IP, computers understand the class automatic, understand the subnet mask from the class automatic. Big disaster, of course. A big waste. Millions of IP addresses gone because you wanted to use 10. So if you wanted to, let's say, waste less, invest more, you will consider Class B, something like 172.16, but it will be /16. So I am wasting over 65,000 IP addresses for 3 computers. I can go furthermore, which is the most specific one, the longest matching one, and that will be /24, like 192.168/24. Yes, in that case, I will be having 254, correct. 256 in total, 2 for the IDs, 254 to be usable. Using 3 of them, what's left is wasted. You'll say, why wasted? I can use it. You can't. You can, but within the same domain. If you want it to be on a different domain, you have to refer to another network. Like what? Like 192.168.1.0/24. And then another network, 192.168.2.0/24. And the third, another network, 192.168.3.0/24. On and on. This was the disaster of classful. And you need to understand it in that way. What happens is that with CIDR, we are breaking this, and I will delay it until the class, or let's say the lesson of the CIDR. Now, another topic before I finish this video, because it's super simple, is that are you allowed to use any single IP that comes to your mind from the 4 billion addresses? Or are you allowed to use couple of billion of IP addresses, here. Are you allowed to use that with full comfort, full flexibility? No. Why? If I used 1.1.1.10 on my computer and I connected to the internet and I started sending packet and traffic to the internet using this IP, what denies the other 4 billion humans that has internet access worldwide nowadays from using the same IP? Nothing will deny them. If they didn't use the same IP, what will happen? The internet routing table that is at the moment of recording this video has around 1 million subnet, aka prefix, installed inside it, will receive thousands and thousands of different requests from different locations, all having the same IP. So upon replying, it will reply what, to who, and how, and where's the privacy, where's the security, how to avoid duplicating, how not to duplicate with the same network, how to understand. It is almost impossible. So when they designed IPv4, they also designed types, private and public. They isolated, or let's say furthermore classified from the first 3 classes. From each class, they classified a subdomain that can be used internally, privately, inside a network. Like from class A, they deducted the 10 alone, because class A ranges between 1 dot something until 126 dot something. They only took the 10 and made it private. So the entire 10 private. So if your eyes ever saw 9 dot something, this is a public IP address. If you ever saw 11 dot something, this is a public IP address. 10 is a private. Same story with 172.16 up until 172.31. So 172.16, 17, 18, 19, 20 until 31. So if you ever saw 172.15, this is a public IP address. What's the matter with that? I will tell you in a minute. If you ever saw 172.32 dot whatever, this is a public IP address. Same story here. 192.168 itself as a private. So 192.167 public. 192.169 public. Only these are private. Only these are private. What's the matter here? Well, the matter is as follows. The private inside the network for free, no one will know, will not reach the internet, thus will not be duplicated. So you have a full flexibility of using whatever IP from the private range in your network, design whatever you want, full freedom. The public, paid, distributed, licensed, and registered worldwide can reach the internet, not to be duplicated, not to be used elsewhere, except for a case called the Anycast. I will not talk about it in this course. All right. Well, I should talk about Anycast at the end of this course. I'm sorry, the last video. I should talk about Anycast with the IP services. It will be important. So this is a big difference. So when you study, when you operate, when you build a network for studying, you have to use private range, which was announced officially with the document of request for comment 1918. Please Google that for me, read it, because it will add a big benefit for you. And that's it, just a theory video. You need just to understand some info. You need to know what happened before, what happened later, and what is happening now, which will be in the next video.